Hello everyone. Today we're re-diving into a fascinating story from our solar system about a celestial visitor that has captured the attention of both the astronomical community and space enthusiasts alike, Comet 13P Atlas. And before any wild speculations arise, let's make one thing clear right from the start. We'll prove with solid and irrefutable scientific data that this object is indeed a comet. It's November 2025, and 13P Atlas has just reappeared after a period of being hidden by the intense glare of the sun. On October 31, 2025, the Discover telescope, located at the renowned Lowell Observatory in Arizona, United States, managed to capture spectacular images of the object returning to visibility. These images mark an important milestone. We can finally observe it again from Earth. To fully understand this phenomenon, we need to trace the journey of 13P Atlas through our solar system. Like all comets, it follows a well-defined elliptical orbit, with points of approach and retreat relative to the Sun and the planets. On October 3, 2025, the comet passed relatively close to Mars, the red planet, the first major milestone of its recent journey. Then, between October 27 and 29, 13P Atlas reached its perihelion, the technical term for the point in its orbit closest to the Sun. This is always the most critical and fascinating stage for any comet, as the Sun's heat acts most intensely on its icy nucleus. During this period near the Sun, the comet became temporarily invisible to Earth-based observers due to the Sun's overwhelming brightness, which completely outshone it. Imagine trying to spot a lit candle beside a powerful spotlight. That is the challenge astronomers face when observing celestial objects close to the Sun from Earth. But modern science has its tools. NASA's Punch spacecraft, strategically positioned in space, managed to capture photographs of 13P Atlas even during this challenging period. The images clearly show the comet, and it's worth clarifying an important point about astronomical imaging techniques. When we see streaks of stars in such photos, it's because the camera is tracking the comet's motion. Specialized software can then remove these streaks and enhance contrast to reveal fine details of the object being studied. Looking ahead, December 19, 2025, will mark another significant moment, the point at which 13P Atlas will pass closest to Earth. This will likely be the best time for amateur observations, when smaller telescopes may capture intriguing images. And to complete its journey through the inner solar system, in March 2026, it will make a close approach to Jupiter, the gas giant. It's also worth noting that during November and part of December 2025, the JUICE spacecraft, Joint Investigation of the Comet Universe in Space Environment, may obtain valuable observations of the comet, filling in data gaps that Earth-based observatories are unable to collect. Oh ChatGPT Dees, now we arrive at the most fascinating and technically rigorous part of this story. The irrefutable scientific proof that 13P Atlas is in fact a comet. And how do we know that? Through meticulous analyses of its magnitude, brightness, and spectral behavior, researchers from various institutions around the world have compiled data from multiple observation sources. We have measurements from the Minor Planet Center, MPC, data from the Comet Observation Database, KOBS, information from the Secchi coronagraphs, and observations from NASA's Punch probe. Each of these sources use different instruments, independently calibrated and based on their own methodologies. When all these data sets were plotted on graphs relating observation dates to the object's apparent magnitude, something extraordinary happened. There was an almost perfect match with theoretical models of cometary behavior. We're not talking about a rough approximation, but about a precise correspondence that leaves very little room for doubt. The theoretical models used were built on the well-known behavior of other comets within our solar system. When we create a mathematical model describing how a typical comet should behave as it approaches the Sun, accounting for factors such as ice sublimation, coma, and tail formation, and solar radiation pressure, and that model aligns perfectly with observed data from a new object, we have solid scientific confirmation of its cometary nature. One of the most revealing aspects was the detection and characterization of the coma of 13P Atlas. For those unfamiliar with the term, the coma is the temporary atmosphere that forms around a comet nucleus as it approaches the Sun. It is literally a cloud of gas and dust that envelops the solid core. Analyses revealed two distinct components of the coma, the dust coma and the gaseous coma. In the scientific graphs, the red line represents the dust coma, and it's remarkable how the observational data align perfectly with this model. The dust released by the comet reflects sunlight in a characteristic way, creating an unmistakable spectral signature. But the most striking observation was the behavior of the gaseous coma. As 13P Atlas approached the Sun, its brightness increased dramatically. The magnitude dropped below 10, representing a significant surge in luminosity. This behavior is exactly what we expect from a comet. The Sun's heat triggers the sublimation of ices that make up its nucleus. Sublimation is the process in which a substance transitions directly from the solid to the gaseous state, without becoming liquid. In the vacuum of space and under intense solar radiation, the ices of water, carbon dioxide, methane, and other volatile compounds in the comet's nucleus sublimate rapidly, producing the characteristic gaseous coma. The data collected by coronagraphs during the period when the comet was behind the Sun were particularly valuable. Even from this extremely difficult observational position, the instruments managed to measure the object's brightness, and here, as the crucial point, those measurements matched perfectly with the predicted model for the gaseous coma of a comet at perihelion. What makes this confirmation even more robust is the convergence of independent evidence. We are not relying on a single telescope or one observation technique. There are data from ground-based telescopes across different observatories, data from space coronagraphs, and even data from interplanetary probes, all pointing to the same conclusion. This multiplicity of sources is fundamental to the scientific method. When different instruments, operated by different teams and using different methodologies, all arrive at the same result, the reliability of the conclusion increases exponentially. It's like having multiple independent witnesses confirming the same event. The mathematical models used were not created specifically for 13P Atlas. They are based on decades of observations of other well-known comets within our solar system. When a new object behaves exactly as those previously validated models predict, we have a powerful confirmation of its true nature. It's important to address the speculations that inevitably arise whenever unusual celestial objects appear. Some have suggested that 13P Atlas might be an alien spacecraft or some form of extraterrestrial technology. While such ideas are fascinating in the realm of science fiction, the observational reality is far more ordinary and, in its own way, just as captivating. An artificial object would display a completely different spectral signature. It would not exhibit the characteristic gaseous coma, nor would it respond to solar heating in the same way comets do. Most importantly, it would not follow brightness models based on the sublimation of ices. The remarkable consistency of the collected data with established cometary models effectively rules out any exotic explanations. The case of 13P Atlas perfectly illustrates how science works. We begin with observations, gather data from multiple sources, apply theoretical models based on prior knowledge, and then test whether those models adequately explain the new findings. When everything aligns, and as it did here, we gain not only an answer but confidence in that answer. Modern astronomy is a collaborative and international science. The data confirming the cometary nature of 13P Atlas came from institutions around the world, using instruments both on Earth and in space. This global collaboration is essential for unraveling the mysteries of the cosmos. Therefore, it is scientifically proven beyond any reasonable doubt. 13P Atlas is definitively a comet. It is not an alien spacecraft, not an unusual asteroid, and not any kind of mysterious or unexplained phenomenon. It is a comet behaving exactly as comets are expected to behave. The magnitude data matching dust coma models, the brightness increase at perihelion aligning with gas coma predictions, and the independent observations from multiple instruments all converging on the same conclusion, this represents the scientific method at its finest. This is a powerful educational example of how we separate facts from speculation, how we distinguish science from pseudoscience, and how methodological rigor allows us to truly understand the celestial phenomena we observe. Science may not always be as thrilling as tales of alien encounters, but it has one priceless virtue: it corresponds to reality. And let's be honest, a comet, traveling through our solar system, sublimating primordial ices that have existed since the formation of our planetary system 4.6 billion years ago, carrying clues about the early conditions that led to the birth of planets and even life itself. That is utterly fascinating on its own. 13P Atlas will continue its journey through the solar system, and we will continue to observe, measure, and learn. Because that's what we do. We study the universe not through speculation or wishful thinking, but through careful observation and rigorous analysis. And in doing so, humanity expands, step by step, its understanding of the cosmos we call home.